OOP, or Object-Oriented Programming, is a way of writing programs where we organize everything into objects. Let's take a closer look at it. An object can be really anything. It can be a dog, a student, or even a UI element such as a button. We can think of it as a model of a real thing that has characteristics that we call attributes or fields, and behaviors called methods. For example, a student object can have characteristics or data like name, ID, year level, and behaviors like study, take quiz, and take exam. In OOP, instead of just writing a list of instructions, we model our code around real-world entities. OOP allows us to write much cleaner code with none or minimal code duplication, therefore making programming more organized, reusable, and closer to real life.
When writing code, we aren't limited to follow one singular approach. There are different approaches or styles that programmers can use to solve problems. Let's take procedural programming and object-oriented programming as examples of two different coding approaches. In procedural programming, the flow of the program is like a straight line, a single path of instructions that the computer follows from start to finish. Meanwhile, object-oriented programming breaks the program into classes and objects, where each part has its own role and behavior, working together to complete the task. Let's have two examples. Both of these programs solve the same problem, representing a student and their actions, but they do it in two different ways. In the procedural version, the main method runs the instructions directly. It sets the student details, then calls the study, take quiz, and take exam function one by one. There's no real student, just a series of steps being executed in order. In the object-oriented version, the set of instructions are separate from the main class. With this, we can create a student object that holds its own data and knows how to perform actions like studying, taking a quiz, or taking an exam, making it so that the program can store many different instances of a student. Now you may ask, why should we use OOP over different approaches like the procedural approach? Great question. Just like its importance, object-oriented programming offers several advantages. These include writing clearer and better organized code, promoting reusability so that the same code can be used multiple times, and making programs easier to manage by breaking the entire system into smaller, well-structured parts. Now that we know what object-oriented programming is and how its approach works, let's move on and talk about some of the key concepts that exist within it. One concept to note are classes. A class is often considered the core of OOP, since it acts as the blueprint or foundation for everything built in this programming style. By itself, however, a class doesn't create anything. Instead, it provides the structure or plan that objects will later follow. You can think of a class as a template that describes what an object should look like and what it can do. Using the same example from earlier, the student class acts as the blueprint that tells us what a student object should have and what it can do. But what is an object anyway? While a class only describes what something should look like or do, an object is the real version that actually does it. By applying the same class from earlier, we create an instance of it. This allows us to use the student class as a set of instructions that our object can follow to perform tasks, like changing different values, and uses different methods, while also staying unique towards the object created.
Moving on to the next and final topic for this video, we'll tackle encapsulation. Well, basically, encapsulation is just a technical term for covering or data hiding. It matters when you want to specify which people, packages, classes, or methods can access your data. To demo it, this is a code sample without implementing encapsulation. And this is the code after implementing encapsulation. You can pause the screen for a moment to check the differences. Basically, in implementing encapsulation, we need to change the access modifiers of our instance variables from default to private. Then, create getters and setters for each instance variable with a public access modifier. Or don't make all of them, depending on if you demand it or not. Getters are basically just a suffix to your object name starting with a dot. Then it works as a grabber of what is the value of that specific variable in your specific getter method by using the return keyword. Remember that when using getters, you change void with the data type of the variable you want to get. Setters, on the other hand, demand a value that comes in through the parenthesis with the intent of changing the value of your instance variable. We write setters with a public access modifier, void return type, method name with prefix set, and a parameter containing the data type of the value that will go in, and lastly, a user-defined variable name. Unlike getters, setters don't need the return keyword at all. To see this in action, this is a sample code in our main method. And finally, this is the output in our console.